Hi, I'm Jay Surya. In this video, we'll see what binary search is, how it works, and where it is used. So let's take this array for example. How do we normally search through an array? We start at the beginning of the array and we go element by element to find the target element. So this is known as linear search. Linear search is an algorithm where we search through an array in a linear fashion or a sequential fashion. Okay. But when it comes to arrays of higher lengths, like if the array has 1000 elements or a million elements, linear search can be really inefficient and slow. Okay. However, in our case, since the array is sorted, we have a more efficient approach known as binary search. Okay. So binary search is a method to efficiently find the position of the target element in a sorted array. Okay. So instead of going element by element, it divides the search space by half in each step. Let's go through an example to understand how binary search works. Okay. So I will first take a target element. My target element will be 71, let's say. Okay. And binary search uses two pointers. One is the low pointer, one is the high pointer. So low is pointed to the first index and high is pointed to the last index of the array. So in step 1, we find the middle element. So middle equals low plus high by 2, 0 plus the index, 0 plus 7 by 2. That is 3 in integer. Okay. So the index 3 represents 45. So we compare it with the target element. It is not equal to the target element. So we check whether it is lower or higher than the target element. Since it is lower than the target element, we are very sure that it will not be more lower than this and it will not fall in the left hand side of the array. So what do is, we omit the left hand side of the array and we cut the search space by half here. Okay. So by doing this, we reduce the number of elements that we need to search next by half. Okay. So in step 2, we again follow the same method. Okay. So this will be my high now and this will be my new low. Okay. So I'll again calculate the mid and if I see the mid will be, this is 3. 3 plus 7 by 2, 5. So this is my fifth index and I'll check it with the target. Since it matches with the target, my search is completed now. So for an array of 8 elements, it only took me 2 steps to find out the target element. Okay. So we can see that how efficient binary search is when compared to linear search, because linear search would have taken 6 steps to find what the target element is. Now let's move on to time complexity. Okay, so we compare the time complexity of linear search and binary search. So the worst case is when the target element is in the end of the array. So linear search will traverse through the entire array. So the time complexity will be O of n, where n is the size of the array for linear search. For binary search, since it divides the search space into half in each iteration, it follows a logarithmic function. So the time complexity for binary search will be O of log n. So in our case, n is 8. So log 8 to the base 2, 3 is the maximum number of steps to search an element in an array of size 8. Okay. So as the array size improves, binary search becomes more efficient. An interesting fact is that for an array of 1 million elements, binary search takes just 20 steps to find the target element. Okay. But for using binary search, we need 2 constraints that needs to be met. First is random access. So we should be able to access data in any index randomly in a constant time. So this is possible in arrays, but this is not possible in data structures like linked lists. Okay. And the second constraint is sorted array. The array should be sorted for binary search to work. So in case we are searching, we are going to search only once through an unsorted array, then using linear search is a better option, because the average time complexity for sorting an array is n log n, big O of n log n. So linear search is much lesser than that, so linear search is better. But in case if we are going to search multiple times for the same data, then it is worthwhile to sort the data and use binary search. So now we know when to use binary search. Some of the real world use cases of binary search is searching through an word in dictionary or searching through a name in a phone book. Okay. So that is all about binary search. Thanks for watching.